Physics Bites.
Physics Bites,
A science podcast in English by the students of Notre-Dame d'Ascension.
Hello and welcome to Physics Bites, the English language physics podcast of the students of Notre-Dame d'Ascension here in Paris. We are continuing with our junior class project on SETI, the search for extraterrestrial intelligence. We have our second group. They specialize in talking about the science behind SETI. So we have 4 students. I'm going to let them introduce themselves.
Hi, I'm Sophia.
Hi, I'm Alice.
Hi, my name is Linn.
Hello, I'm Matilde.
So we have Sophia, Alice, Lin, and Matilde. So you guys talked about the scientific side of like the technologies behind what we call SETI. You went through a whole bunch of stuff, but before we get into the details of it, maybe Alice, you can just sort of give us an overview of the stuff you guys presented to the class and what you guys discovered in your researches, and then we'll go into details.
Yeah, so as you said, our subject is science of SETI. So we're going to talk about different ways scientists look for life. So there is spectroscopy, where we basically study light from space and try and understand what stars and planets are made of. There is radioastronomy, which means we use radio waves to observe the universe and look for unusual sounds. There is detecting and analyzing signals to see if they come from artificial or natural sources. And there's sending signals to see how we can communicate across space.
Right, and that last part, sending signals, is the subject of another group that worked on the whole active SETI and the messaging extraterrestrial intelligence. So basically, if I sort of can summarize it, your technologies were kind of divided into 2 groups. One part is capturing the signals, and the other is like analyzing and seeing if we can find anything of value in there. So why not begin with how we capture these signals, right? So you mentioned generally you have 2 main technologies. We talked about radioastronomy and spectroscopy. Maybe we can start with spectroscopy. I think, Matilde, you were the one who talked a little bit about that. Maybe we can go just into an overview of what we mean by spectroscopy and how it's used in SETI.
So, yes, spectroscopy is based on the light. So, light is everywhere in the universe. So the light is white light is composed of the colors of the rainbow. Mm-hmm. So and these colors actually have different wavelengths, and so spectrometers are using refraction of these lights, which bends at different wavelengths, as I said, mm-hmm. and different angles, and this allows spectrometers to eventually see the different wavelengths. And
so, just to yes. get the first part, spectroscopy is basically looking at light coming from any source. In your case, I guess it would be extraterrestrial sources, and we're taking the light coming there and we're analyzing it to its components, which are different colored lights. How does this actually help us with the search for life outside of Earth, or intelligence or civilization outside of Earth?
So each molecule and atom have a specific wavelengths, and mm-hmm. By analyzing the different wavelengths that you can obtain, you can know which element is in
is present in like the atmosphere of whatever.
Yes,
we're studying.
Can be the atmosphere, and the most important is that we can eventually find life or traces of life, mm-hmm. Find water or like these things. So it is used in the Hubble telescope and on rovers on Mars currently.
Okay. And I think so the idea is that for one, we can sort of detect the presence of elements that could be necessary, which could indirectly point to conditions that are necessary for life. And on the other hand, we can also use it to detect signs of maybe activity by some sort of a life form on that planet or on that whatever celestial object that we're seeing. And we are using spectroscopy currently to observe for signs of extraterrestrial intelligence, or no? Do you know?
For the moment, it is only used as eventual identification of sites which could eventually have life, but it is not sure. There is no proof for the moment that we found specific things related to extraterrestrial life.
So in general, I think we can say that spectroscopy is something we use a lot already in science. It can be used to detect whether a planet could be a good host for life, but it remains like a very preliminary sort of tool in the search for extraterrestrial intelligence, if I understand correctly. Alice, if I'm not mistaken, you and Linn, you both talked a little bit about detecting signals using radio telescopes, right?
Yes.
Linn, do you want to maybe talk a little bit about radioastronomy in general, why it is so prevalent in SETI research, and then we can go into some other details?
Sure. Is in SETI, we can't always find an intelligent civilization based on resources, which means that we need to find a way to communicate fastly with other civilizations without spending too much resources or energy. And that's why radio astronomy is so important, because it can travel at light speed, and also it can encode the signals such as music or television programs. So it is really helpful when we try contacting a civilization that is like light years away from us.
Okay, so because it's using electromagnetic radiation, kind of like light also, which was used in spectroscopy, it gives us access to distances which are on the cosmic scale. On the other hand, why is radio astronomy almost preferable as a tool to, for example, just normal telescopes and normal astronomy with like visual elements? What's so special about radio astronomy when it comes to SETI research and potential extraterrestrial life?
It is important because first we think that another civilization would also use radio waves to communicate, because actually it is one of the fastest way an intelligence civilization could use to communicate, and so that's why a lot of our radio waves could have been leaking into the universe for years. So it is very important when it comes to SETI, because it permits us to go far, and it can go through gas and dust. So which means that if a civilization is too far or is covered in gas, we can still contact them, because the radio waves will be able to reach them.
Okay. So on the one hand, there is the ubiquity of electromagnetic radiation. Pretty much any civilization which can be considered a civilization would know how to manipulate the electromagnetic spectrum. So if we can detect it, we can have a good chance of saying that it can be a sign of intelligent life. And on the other hand, it's a great means of communication, as you're saying. Okay. Alice, I think you wanted to add a little something to the whole radio astronomy discussion.
Yeah, so I just wanted to say that radio waves are a main tool for this search, because they travel huge distances and pass easily through cosmic dust. So it's pretty simple for us to detect them. And one of the other things we search for is something called a narrowband signal.
Right, you mentioned that in your presentation. Do you want to give us a few details what that is and what is the importance of it when it comes to SETI?
Yeah, that just means a signal that appears at one super specific frequency. So it's kind of like a perfect thin spike instead of a white fuzzy shape, and nature rarely produces signals that precise.
Right, so if we want to make an analogy of it, for example, we can compare light, like from a light bulb compared to lasers. The light coming from a light bulb, it has all sorts of colors, so it has all sorts of frequencies and wavelengths, and there are many sources in nature that produce that kind of a wide spectrum light. But lasers, which have just the one frequency because it's coherent light, there are not too many natural sources. So if we do detect some sort of a signal which is that specifically on a narrow band, then for you, or for at least SETI research, is considered something that is a good candidate for something artificial or created by some sort of an intelligent life form. Okay.
Yeah, because technology transmitters, antennas, and radios often produce very narrow and sharp signals, so it's very rare to find that.
That's how our own radio and television waves work, right? Have we detected any sort of narrowband emissions that could be candidates, or do you guys know?
Well, I know that scientists usually focus on certain frequencies, like one known as the hydrogen line,
right,
which is 1,420 megahertz.
I'll take your word for it.
And so one very famous signal detected was the WOW signal.
Right.
That was detected right around that exact frequency, and scientists think...
When was this? Do you remember?
In 1977.
Right, so this is like 50 years old, 60 years old almost at this point.
Exactly.
Okay. What was it? Did we ever determine whether it is communication from aliens?
No.
Or...
Yeah, no, unfortunately, we still don't know what it meant. And because it's one of the most... Hydrogen is the most common element in the universe, scientists think that an intelligent species might choose this frequency to send the signal.
As a way of saying, like, we know about hydrogen, we know about, like, the resonant properties of hydrogen, and it's a way of not just transmitting information, but also showing their own sort of intelligence or civilization and scientific knowledge. Okay. Are we still searching for this kind of stuff when it comes to radio signals? Are there groups, anybody in the group, are there research groups that are actively searching and trying to get an idea of like hoping to capture something, or do you know? Everybody's looking at each other a little bit.
Well, people do use extremely sensitive telescopes, and so in California there was a telescope designed specifically for SETI.
Right. What was it called? Do you remember?
Allen Telescope Array.
Right.
So it uses dozens of antennas, so it's pretty fascinating because it's going to scan wide frequency ranges and look for suspicious spikes. And
so what do we mean? Just let's get into because since you guys are the focused specifically on the technology and the scientific side of it, what is an array of telescopes? Is there a difference between like just a normal telescope and already like with a radio telescope? Does that look like a telescope like that we see from like pictures? Does it have a specific form to it? Whoever. Well, go ahead, Alice.
I think when I looked it up, what really marked me was that it was the size of a valley. Mm-hmm. So that's not how normal telescopes look like. Right. And it's also in a big shape of a bowl. Right. And there's a big antenna pointing out.
Right. So this is the specificity of radio telescopes, because they're not aimed at capturing light. They don't look like our notion of what a light-based telescope looks like, but they look like basically anything that could capture a whole bunch of radiation coming in. The bowl shape sends it to the antenna in the middle, which gets all the information, and then we analyze it on the other side. So what is an array then, as opposed to just a radio telescope? We saw this also in the movie In Contact.
I think it's when like there are multiple telescopes which are combined. Yep. So using interferometry, they can amplify the signals they receive, and so they have more precision on the signals they receive, which is perfect for SETI research.
That's it. So instead of having just one telescope, you have like many, and they're all looking together. So it increases like the scope of the thing. Let's talk again a little bit about the signals that we can capture. What are we looking for when we look at the signals that could be a sign for something that is not just a natural process creating this?
Yeah, so there's a lot of noise in space, so we have to figure out if it's an artificial sign. And so first, what analysts will do is they will isolate the carrier, so the strong central frequency, and then apply filters to just remove the rest of the noise. Okay. And then
so we know what some of the noise should look like. Like we know what certain like celestial objects look like when they emit stuff, so we can filter it out. Yeah, I think Alice, you wanted to sort of add a little.
Yeah, because the universe adds its own complications, as you said. So there's gas clouds that can absorb or distort radio waves, and plasma, which is a mix of hydrogen ions and helium ions that are near stars and that can scatter signals.
But we know these sources, right? So we can sort of erase that from the signal that we capture. So you were saying, Sophia, then what are we looking for now that we've filtered out all the noise, as you called it?
So then when we try to decode the signal, we ask questions like, for example, if it uses like math or physics or chemistry, because they're all signs of intelligence. So like prime numbers, repeated sequences.
It's a very classic sort of idea that if there's an intelligence out there, they would know about prime numbers. It's a universal concept.
Something structured.
You also talked about, I think it was Alice who mentioned it, but anybody can answer. You talked about notions of narrowband signals. You talked about frequency drift. You talked about if it's coming from a specific point or from various points. Can you just give us an overview of what you mean by all that, all these different criteria for qualifying a signal as a potential candidate?
Yeah, so the frequency drift, it's a slow shift in the frequency of a signal over time. So you can imagine the pitch of a sound slowly rising or falling. So this creates a Doppler effect.
Doppler effect.
I'm sorry, but you minded me.
We're going to study that next year in your senior year.
Perfect. But you might be wondering what the Doppler effect is, and it's a very good question, and I'm going to answer.
The listeners of our podcast ask often quite good questions, so that's why we count on you guys to be here to anticipate and answer those ahead of time.
Well, the Doppler effect, if you've been wondering, is a change in the frequency or pitch of a wave. So it's caused by the motion between the source and the observer. So,
you're allowed to breathe at the same time. It's okay. It helps even.
So that's maybe because the transmitter that's on a distant planet and the receiver that's on Earth are both moving. And so planets spin, orbit their stars, and stars move through the galaxy. So that's why it's very important to find frequency drift.
Which in a way would indicate that the emitter is located on a planet, which is a good sort of criterion to look at, as opposed to coming from just sort of processes that are in space or in nebulae or anything like that.
Exactly.
Okay. So I think we've gone through most of what we wanted to talk about with radio astronomy. Is there anything that you guys wanted to add that we didn't cover?
Yeah, maybe we can just
Sophia?
talk about how we can interpret the meaning of the messages after we've decoded them.
Right, so now we're going to the second half of, I guess, the stuff that you guys were talking about, which is basically, okay, so now we've talked about the different technologies that capture all these signals. How are we going to interpret this? Because like you already mentioned, Sophia, there's a lot of noise. So let's get into that then.
But I meant more like after we've decoded the message, like how we...
Well, let's decode the message first. How about that, right? So I'm happy that you guys are very curious to know what the aliens are trying to tell us. But before, let's get the message out of the noise, right? So, how do we analyze these signals?
They
Linn?
can use data learning machines. So like AI, because AI is a very powerful tools to recognize the patterns. So it can help decoding the signals.
Right. So this is one of the more modern things because, as you guys are very aware, we've had a lot of advances the last 10 years in machine learning and training of artificial intelligences. And they might be bad at a lot of things, but they're good at detecting patterns in tons of signals and in a quick manner. So I would imagine, like you're saying, that we're using more and more specifically trained AI for detecting and sort of studying and analyzing these things. Is that it?
Yes.
Okay. Do you know of any in particular, for example, that have been trained or being used, or not really?
Not really.
No, I think it's a very specific research. But Sophia, you did talk about how we analyze these signals, and you sort of went through the different steps, what we're looking for, and like how we go about this. So.
Yeah, so we have to deal with the propagation effects and the distortion because so the interstellar medium can smear or distort signals. Okay. So we try to, we don't try, but like researchers try to model the effects to undo them. And then, so if we fail to correct them, then that's one reason that two teams can arrive at different decodings of the same message.
So I guess it depends on the criteria that you would consider as important to sort of isolate or to eliminate, right? And I guess the real question is, how do you how do you decide what is important, what is real, what is actually being generated artificially? What did you find in your research?
Well, as I said, it's just like something that indicates meaning. For example, if there's a pattern that's repeated multiple times, it's just like for us, when we repeat something multiple times, is to put emphasis on it. So that might be a sign of intelligence. And then stuff like math and everything, like binary system, like with ones and zeros,
right.
Which it's simple and it's unambiguous, so it's a clear sign of intelligence usually.
The feeling I get is that in general we're going to really depend on some sort of a mathematical structure, because I guess math, we would hope, is something universal, right? So there has to be something that resembles a mathematical pattern, I guess, in there. Again, I'm going to ask you the same question. Outside of the famous WOW signal, have there been any other signals we've ever captured that could be candidate?
Well, we haven't found any other signals. Well, I don't think so.
Okay.
And a few famous mystery signals only turned out to be microwaves opening too quickly at observatories because Earth is incredibly noisy in radio terms.
Right, because mostly from our own sort of activities, right?
Exactly.
Right.
And Earth's own military radars are so powerful that under perfect conditions, they could theoretically be detected by a civilization that's thousands of light years away.
Okay. But it can also trick ourselves, right? I guess it's sort of like the UFO debate. Like pretty much everything we thought with a UFO was something that we were doing ourselves, probably something military, so most people don't know about it, so we end up thinking that it's aliens. Wishful thinking, right? Okay. Yeah, this question of Earth being noisy, I guess, goes back also to the whole question of how to filter out the noise. Because we know the noise that we create. The question becomes, what is the noise that we don't create that is naturally produced? Okay, so I think we've gone over most of the main points that you guys found in your research. Is there anything else that maybe you guys want to bring up that I didn't necessarily mention or we haven't sort of gone into details about? Alice?
Yeah, so maybe how do scientists detect a potential extraterrestrial signal? We talked about it a bit, but I would like to talk about it more.
Sure.
So they're going to choose target stars, especially ones with known exoplanets.
So what is an exoplanet? Do you guys remember?
Yeah, like an exoplanet is any planet beyond our solar system. And so there are 4 types of exoplanets. The gas giants that are the largest, like
Jupiter or Saturn in our own solar system.
There's Neptunian planets like Neptune, so super Earths.
Which are a mix of gas and liquid, I guess. Yeah.
Yeah, but a bit lighter than Neptune and more massive than our Earth.
Yeah.
And also terrestrial planets that are a bit smaller than Earth and are mostly composed of the same thing as...
Right, so solid, mostly rock and metal, I guess, in a way. Okay. So, exoplanets, you were saying, Alice.
Yeah, exactly. And they're going to scan the sky across wide frequency ranges. And they're going to look for narrow spikes, as I told you earlier, that don't match natural patterns. They're going to measure a drift to see if it behaves like a transmitter sitting on another planet.
Right. Moving away steadily or moving towards us steadily.
Exactly. And then they're going to return later to see if it appears again at the exact same spot. And it's going to remove as much human interference as possible, which sadly represents a lot of signals.
Which is fine, because at least it's signals that we know, so we can filter it out more easily, right? So as opposed to if there was a lot of noise and we weren't producing it, then it would be much more difficult to sort of know what is actual noise and what is not actual noise. So let's be positive, right? Lynn, at one point you talked about radio-interferometry.
Yeah.
What is that all about?
Interferometry is basically when 2 waves or more overlapped. And so we do that by combining multiple radio telescopes together, so we can simulate a larger telescope, and it increases the resolution of the signals we receive.
Okay, and how do we use it? What is the use of this? So it's only to make the signals more easily detectable, is that it?
Yeah, because it increases the sensitivity of our observations.
Okay, so because most of these signals are coming from a very far distance, they're going to be attenuated when they arrive, and so anything we can do to amplify the power makes it easier to detect like the details if there is anything in there. Okay. All right. So let's just out of curiosity, what are some? Do you guys know what some sources of natural radio noise are in the universe? You talked about plasma and like nebulae and like gas clouds. Are there other sources of other radio sources?
Not sure, but there are also pulsars and quasars.
Right. So, two very different things. Do you know what pulsars are?
I think that pulsars are...
This is very advanced knowledge. We don't do this at all in school, so anything that you know is beyond the scope of what we've done. So,
they are, I think, dying stars. So they emit light and radiations.
Okay.
And we can pick that up with radioastronomy.
So it's a bit kind of true in the sense that there are the remnants of dying stars. What they are is basically what we call neutron stars, which are stars which often are left when a star explodes. It's basically a giant clump of neutrons. And pulsars are neutron stars that are turning. They're doing really, really fast rotation. And because of that rotation, they end up sending out these very, very regular sort of radio waves, right? And we can pick them up. And you mentioned quasars. Now, that's a completely other thing.
Yeah,
what is that?
Quasars are basically massive black holes that have debris and dust rotating around them.
So quasars are something that are very, very far away, which means that they're stuff that existed a long time ago in the past, early universe, right? They... to my knowledge, I don't think we have a lot of really detailed knowledge of what they are. What we know is that they are very powerful sources of radio signals, right? So to be able to traverse like that distance in space and time to reach us means that the amount of energy is really huge, right? Okay, yeah, Alice, I think you wanted to add something.
Yeah, because you talked of natural radio noises. There's also galaxies that constantly hum, and as
humming galaxies, so poetic.
Yeah, it's very cool. And as Lin said, pulsars, and you said that they were spinning, so it's going to create repetitive bursts like cosmic lighthouses.
Exactly. Very good. It's a very good metaphor. The difference being that it will be turning like many times a second, which is insane when you think about a star turning on its axis many times a second. And that's a testament to the huge gravitational forces that are involved. So we know that what you mean by hum then is that they're sort of sending out this steady radiomagnetic, I guess imagine low frequency sort of signals. Okay. So what you guys are all saying is the universe is very noisy despite the fact that we can't hear anything in space. Just have to look in the right direction. Okay. So let's turn more to, I think, just the topic in general, because so I asked this question from every group and I'm going to ask it from you guys as well. So I imagine for most of you guys, this was a brand new topic, right, SETI? I don't know to what degree you knew that such a thing existed. I think in the popular culture, aliens are either inspiration for a horror movie or like science fiction movies, right? But I'm hoping that you guys realize that there's a lot of actual science behind this, right? So let's go around the table, and I want to see what you guys thought about the topic, first of all, your topic, which was specifically about the science and technology behind it. And then maybe if you want, you can sort of freestyle on what you thought about the topic in general, SETI, search for extraterrestrial intelligence. Maybe we can start with Matilde.
Okay, so I found that SETI was actually really interesting. I wasn't thinking about that it was so complex, and for me, like, aliens was just kind of a silly thing. Like in pop culture, you see so many references.
Little green men, right? That's what we called them in the 1950s and 60s.
Yeah,
right? Yeah.
I actually have one on my phone and one at home.
There you go. Marvin the Martian, for those who are old enough to remember.
Yeah, and I wasn't thinking about that it was so serious, that there was a plethora of like scientific research on this, and this was really interesting to see all the technologies used and to be able to see how it works. Mm-hmm. So yeah, it was really enjoyable.
So it's a discovery for you. Maybe we can go to Linn?
I didn't even know that SETI was a thing before like getting to DNL. But at first I was it was hard to apprehend the subject because we didn't really find anything yet. So to me, it was really confusing.
Right.
And also because it was so precise and radioastronomy was such a large subject, it was hard to find stuff to talk about.
Where do you start? What is important?
Yeah,
what is not important? Right.
So like when I got into the subject, I felt that maybe we could use more researchers, but at the same time, I could feel that we cannot make much progress with the resources we have right now. Our technologies are not powerful enough to capture a signals that are like millions of light years away, and that is a huge issue. So to me, SETI was really was kind of interesting to look at, but I felt that at least in my life, I wouldn't. We won't get any farther than we can.
No, so a bit more, I wouldn't say skeptical, but more reserved about the prospects of SETI, which is fine. Alice, how did you feel about the topic? What are your thoughts?
Yeah, so just like Lin, before I didn't even know it existed, honestly. But after doing some research and looking at a lot of videos, I found it so cool that people were actually looking for, like, I don't like the term aliens, but extraterrestrial intelligence. And I find it fascinating that people and scientists are searching for extraterrestrial intelligence, and I think it should be way more famous, because when I talked to it about some of my friends, none of them knew how it worked, and so I think it should be way more popular, because I'm sure
So we'll come back to, because one of your classmates had a question about the whole thing. She was also very enthusiastic, but we'll come back to it. So Sophia, what did you think about the topic?
I knew about SETI vaguely, but I thought it was just.
How did you know about it vaguely? Because I'm surprised, actually. Okay.
Yeah, I just heard of it, but I thought it was like just one or two like small organizations that were looking for extraterrestrial life. But I think it was really interesting to get into like really like concrete parts of it, because a lot of other presentations that we have, they're more abstract, but we can really focus on like things that are already happening with like the scientific aspects of it and the techniques, even if we haven't found anything yet. I think it's interesting.
Okay. So let's close up on the question that one of your classmates asked, was who also, like you guys, was very surprised at the seriousness of SETI research and found it absolutely fascinating and very enthusiastic about it. She asked, what can we do to make SETI more mainstream? And I think the question is kind of interesting, because I guess we can ask the question, why would we want to make SETI more mainstream? But at the same time, we can ask that question about any sort of scientific research, right? And I guess the answer coming from somebody who teaches science would be, it's always better to know than to not know. But I'm curious to hear from you guys, first of all, what do you think about the idea of making SETI something more prominent and more, I guess, present in popular culture in a scientific way, and then how to go about something like that? Whoever wants to take the lead on this one.
I think it's pretty important to like make people know about it a lot more, because as we said, like none of us really knew what it was about, and I think it would really be helpful to have more people know about it so that they can participate and help and like maybe like finance some projects and stuff like that, so that we can have more chances to actually find something.
Would you be happy at the idea of being able to detect something from an extraterrestrial civilization?
Yeah.
Is the idea something that, because we're going to have this discussion with one of the other groups, but let's ask you guys, would you be more scared of hearing the news that we have discovered an extraterrestrial intelligence, or would you be more optimistic about it?
I think personally I would be more scared, because we never know, it's going to change the world like completely.
Okay, well that's for sure, yeah.
Yeah, and we don't know how we would react and how the other civilization would react, so we don't know what's going to happen at all.
Okay, so you're more risk averse. Okay. Alice seems surprised by your answer, so let's see why. What do you think about it? So the first question was about the idea of streamlining, or not streamlining, but making it more mainstream, the whole knowledge base that we've gathered around SETI, and then maybe how you feel about the idea of detecting maybe some sort of a ET civilization.
Yeah, so I think what would make SETI more mainstream
would that people could share data more, so people could get way more involved and turn it into something more global and not only for scientists. If we had daily information about it, I think people would be able to know the subject way more.
But what is there to be gained by having like the general public be more knowledgeable about something that is so kind of almost esoteric and kind of niche? Why would we want to even do that?
Well, maybe just to show how it works, how interesting it is, how all of even the telescopes, even the thing they use to search for extraterrestrial intelligence, it's really extraordinary how much work and how much time scientists dedicate to this subject. So if people would just see how dedicated some scientists are, it would become way more popular.
Show the importance of it, right? If somebody's willing, with all the degrees and education that he has, to dedicate themselves to something that seems so, I guess, off the beaten path, then it must be something important there. Would you feel happy or optimistic or more scared and sort of skeptical about if you woke up tomorrow morning and the front page was like, oh, we've detected an extraterrestrial intelligence?
I would definitely be optimistic about this. Okay. I would go and I would want
You'd
us
be one of those people with a little poster like welcoming the aliens.
Exactly. I would want to go on the other planet and try and message them back. I would really want to contact them.
You'd want to be part of the diplomatic mission that's going to establish contact, right? All right. It's good to have some optimism here too. Yeah. Linn, what do you think about the whole idea of mainstreaming SETI? How, why, if we should we not?
Well, I think that it's not very important for SETI to be mainstream yet because, I mean, we didn't have a lot of results. So, but if we want to mainstream it, maybe it's important to not to only look at it as a scientist, but also raise more questions, such as philosophical questions, I mean, if we want to make it mainstream, then we have to involve a lot more people than just scientists. So that means that we must talk about economy, we must talk about beliefs, and a lot more of things than just radio waves.
Right. I understand. So for you, what you're saying is that because the topic is something that could potentially have an impact on almost every domain of human life and society, that's one of the good reasons why people should be aware of this and think about it, because then I guess you'd be more prepared for it if one day we do get something. Okay. And maybe to close off, I'm going to ask Matilde, what do you think about the idea of contact with extraterrestrial humans, extraterrestrial intelligence? Would you be more optimistic about it? Would it excite you or would it scare you? And why?
I would be very skeptical of having contact with extraterrestrial intelligence because it's not that I'm afraid of them. They could be really good people. I don't know. But I think that us as humans, we are not ready for this. There are a lot of flaws that we have, and that could be potentially dangerous for them and for us, and eventually cause conflicts and things like this. And
so your lack of enthusiasm comes from skepticism towards us rather than the aliens. You give them the benefit of the doubt, but not ourselves.
Yeah, I think we know the current state of the world right now, and it has been like this for a long time. So there's still really a lack of hope by my side.
Okay, so you're not too hopeful on humans, I guess. Okay, this is a nuanced difference between you and Sophia there. And so we have two happy, enthusiastic people to different degrees, and two more, I guess, skeptical and I guess reserved approaches, which sounds right about where every other group was as well. Okay. All right. I think we've gone over most of the stuff. Is there anything that you guys wanted to bring up that we didn't? All right. Well, that was great. It was pretty interesting for us in the class to have one of the topics which is much more technical than the other ones. We learned a lot, and thank you very much, guys.
Thank you.
So, that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.